Hi, welcome back to another edition of Easy Theory. So let's actually do an example of regular languages being closed under division. So what we did last time is a construction of a DFA where we, what we're doing is we're trying to accept just the W part and not the X part, where the X part comes from this language B here. So originally we would have accepted a string of the form WX, and if X is in B, this other language, whatever it is, then we're going to mark this thing, the original state, as being final. So let's actually do an example, and I have not prepared an example. This is totally off the top of my head. So let's say, let's let A be the set, let's say 0 to the n, where n is a multiple of 3. And let's let B be the set 0 to the n, where n is a multiple of 2. Okay, so a DFA for A would be something like this. So this is a relatively simple DFA to make. So all we're doing here is we're making a cycle of length 3, and so we're going to accept all the multiples of 3, which means we're going to read 1 0, 2 zeros, 3 zeros, and then continue on. Okay, so now what we're going to do is we're going to make a copy of this DFA. So I'm going to attempt to copy it, paste it here, and I'm going to change its color to be blue. So now what and also make none of the states final. So no state is final here. So what we're going to do is we're going to mark states as being final if there is a way to go from that, well, let's just say like this state. If we're going to mark this thing final, if there was a way to get to a final state using a string from B. Well, let's see. If we look at this state right here, and the target state that we want to land in a final state is this one. So that means that if we were to make this state final, we need to read a string that is a multiple of 3, right? So then that means that, let's see, is there a way to read a string that is a multiple of 3 in order to actually get here using a string that is a multiple of 2? And that is, of course, possible because I can read a string of length 6. I can read a string of length 3 and then 3 more, which lands me here, and so is of length 6. So therefore, I will mark this state as being final. And you can probably see where this is going. If I look at this state right here, we got to think, is there a way that I can read a string of length 3, is there a string I can read from B, the language B here, that lands in this state right here? Well, let's see. I could read the string of length 2. So if I start here and I read the string of length 2, I end up here, which was a final state to start with. And the string of length 2 is in here because that's what B is. It's multiples of 2. So this one will be final 2. But now what about this one? So if I would start here and I want to land in one of the original final states. So remember, our construction was to land in one of the original final states, not in the ones we've found so far. So if I start here and I want to get to this state right here, well, reading a string of length 1 ain't gonna help. And if I add 3 onto this, then that means I need to read a string of length 4, and that's possible. So if I read the string of length 4, I will land in one of the final states here. So in fact, all 3 states are going to be final here. Okay? So let's do another example. So maybe a little bit more complicated. So let's do, so here is example 2. So let's let A be the strings W in 0, 1 star, such that W starts and ends with same character. Okay, and then, and I'll show you how to make a DFA for that. And then B, let's just pick a really small language, like 1010 and 00. Okay, again, I'm making this completely up on the spot. I don't have this example done already. So in a DFA for A, so here is a DFA for A, and it's actually really simple. All that you need to do is, well, if it starts with a 0, we got to end with a 0, and if it starts with 1, it ends with a 1. And I'm going to consider the empty string to be an A also. So if I start with a 0, then I need to end with a 0. Well, if I only read that one character 0, I just ended with the 0. If I read any zeros after that, I still end with a 0. And then if I read a 1, I haven't currently ended with a 0, so I need to go to a different state. But if I read a 0 in that other state, I come back. So then I need to self loop on 1 here. Because if I read a 1 here, then I'm currently ended with a 1 and not 0. So then if I read a 1 here, then we're going to have the opposite situation, so to speak. So here we're going to have the transitions basically being flipped. So if I end with a 1, I stay here. If I read a 0, I go over here, and because I need to end with a 1. So and then the 1 transition comes back. Okay, so as before, I'm going to make a copy of this machine. So, and also I need to change its color. Let's change it to blue again. And let's copy down our language B from what we had before. So I'm going to copy it so that we can see it at the same time. Okay, so remember that we're marking every single state as not final, and then we'll mark states as final if there's a way to read some string in here that lands in a final state. So let's see. If for zeros, oops. So let's just consider 0, 0 for every single state here. Is there a way to read from this state right here, going to a final state, going to a final state, reading 0, 0 from here? And it turns out yes, because I could read 0, 0, and this state was final before. So I'm going to mark this starting state as being, oops, wrong blue color, as being final state. What about this state right here? Well, if we read 0, 0, we're going to stay here. And so it was a final state before, so therefore we're good. If we look at this state right here, we actually will mark it as final, because if we read 0, 0 from here, we go to here, read a 0, it was final before, so I'm going to mark it as final. Okay? So now let's come down here. Well, if I read 0, 0 from either one of these two states, I'm going to land in a non-final state. So we better consider the other string now. So if I am in this state right here, and I read 1, 0, 1, 0, that means I do 1, 0, 1, 0, but this state was not final before. So therefore, since we have exhausted all of the possibilities of B for this state, therefore this state will not be final. What about this one? Well, we tried 0, 0, we stay here, it was not final before. Let's consider 1, 0, 1, 0. So if I do 1, 0, 1, 0, again we end up in a non-final state. So therefore, this is the resulting DFA. And what we can see if we actually just write out what the language actually is, A divided by B is going to be, well, if we start with a 0, then no matter what, we will never not accept a string. And if we start with a 1, we'll never accept a string. So what we can do is we can say that it's all the strings, or I can even write it more simply. I can write it as 0 x, where x is in sigma star, because it could be anything. Actually, I'll write it like this. And then union the empty string, because this state is final. So the set containing epsilon. So the language that can result from division here can be completely different from the other ones. Let me know if you were able to find any other interesting examples. And as always, please like and subscribe to the channel. It really helps us out. If you comment, that also really helps. And as always, I'll see you next time.